Okay, we're going to start, so please take your seats. So, thank you for coming to the seminar today. Let's start by acknowledging that the campus of the University of Sydney sits on the traditional unceded lands, the Gadigal people of the Eora Nation. Today we have the pleasure of having Dr. Rosa Felix. Dr. Rosa Felix comes from the University of Lisbon, and she has been visiting us for some months now. She's an expert on active transport, particularly on cycling, and she's going to tell us about the research she has been doing in the last months since she's here. So, without further ado, thank you very much, Rosa, for coming today.
So, first, thank you very much for being here today. I'm going to present the research that I've been working with Professor David Levinson for the last couple of months here at the University of Sydney. And the title is Quantifying the Evolution of Cycling Network Performance, a 50-city panel data analysis using open data. Just to introduce myself, probably you already saw me in the corridors, but we didn't have the chance for introductions. So I'm a researcher at the University of Lisbon, Technical, in Portugal. And my background is civil engineering, urban planning, and a PhD in transportation. And I've been researching topics as active mobility, walking and cycling, connected with behavior change, a lot of GIS and programming. And I'm here for the 4/4-month visiting research periods. So I'll just jump to the objectives of this research, which is to quantify how does the cycling network expansion in the cities impacts the trip efficiency. So in terms of the duration of the cycling trips, the distance and circuity, of course, because they are related. The safety, but translated in the reduction, or how is it regarding to stress exposure measured by the level of traffic stress that I will talk about in a few minutes. How it impacts the accessibility to reach opportunities, and also how it impacts the continuity of the trip. So counted by the number of interruptions when you are using cycling infrastructure. So here CI, when you see CI, it stands for cycling infrastructure, okay? I will use that a lot. So my goals are to analyze this 10-year of cycling network expansion across 50 different cities, to estimate the elasticities of these infrastructure improvements aggregated and by type of cycling infrastructure, and distinguish these effects by type. So just an important thing, this also comes to the objectives, is that this research is using only open data sets that are available, that's not requiring any registration, any API, or any paywall or whatever. Okay. So let me just introduce you the data that was used. So I had to get all the road networks in these cities for different years, and I used the OpenStreetMap GeoFabric server site that has all the backups of the road network existing, not only the road network but also everything that's in OpenStreetMap. And they do this backup at the 1st of January of each year. So when I say, for instance, the network in 2026, I mean the 1st of January of 2026, okay? So I had to collect all this data for all these cities for two reasons. One, to get a full road network for routing, not only the cycling infrastructure, and the other to classify the existing cycling infrastructure by type in each of the years. Another important data set that we used is the Global Building Atlas that was made available by Zhu et al. Recently from the Technical University of Munich. And it has a world coverage data set of all the buildings. So it has details such as the footprint, the height, and so on. You can see here examples of these buildings in Lisbon, Paris, and Sydney. Here are just colored by the estimated number of floors. And this data set was used to generate origin destination patterns. Okay, I'll explain a bit about this later. But as we only wanted to use open data sets, it was important to at least have something that it's not census data, it's not travel survey data. Sometimes those are free to access, but it's probably not as reproducible. If we want to replicate this for any given city in the world, we have to do some search. At least this data set is available for everywhere. So which selected cities? So there is this list of city coordinates from that uses a lot of official data sets like the NASA, US Census, and so on. And there's millions of cities in there. So I just filtered the ones with at least 1 million residents on it. And based on the people for bikes index that as an estimation of how good is the cycling infrastructure in each city, I selected, in that case, 58 cities, but then I had to reject some of the cities because of some details that I'll explain further. But my criteria was to select cities where there has been some cycling infrastructure expansion over the previous decades. So which kind of cities did I excluded? So I excluded 3 cities for like Cairo, Cape Town, and Hong Kong, because they had either no data or they didn't reach a threshold of 100 kilometers of cycling infrastructure by 2026. Cities that didn't expand 10% between 2016 and 2026, for instance, Amsterdam and Stockholm, they're just flat, like growing a bit, but not that much. And some other cities that have some OSM tagging issues, like Munich and Lisbon, unfortunately, and Ljubljana. So I end up having with this 50 city data set. All these cities, they grow in cycling infrastructure network, the kilometers. And there's not like a clear pattern if they grow more in Europe or in North America or in South America. Yeah. And I was looking at these 5 different years. So 2016, 19, 21, 24, and 2026. So let's jump into data processing. So this is just a framework of how I process the data to reach that end of data set that I could then model data, city ear panel data and route ear panel data. So I just use these 2 data sources that I presented before. From each city center, I draw this 10-kilometer buffer around the city center so that all the cities will be comparable and all the amounts of cycling infrastructure and road infrastructure will be comparable. Then I just had to sample the OD pairs, 20,000 of them. Then download all the OSM for all these years and do this custom cycling infrastructure classification. Then I just put this in the routing engine to route by bicycle all the 20,000 OD pairs for each city for the different years and for different levels of traffic stress. And then all in the end, just extract some metrics from that. Just as a benchmark, each city took about 20 minutes to run all the pipeline, and there's tons of data being generated with this, about 3 gigabytes. The tools that I use were mostly R with these packages, DuckDB just to connect to the Global Building Atlas, Java and the R5 for the routing engine, and also the Gemini for scaling up my scripts to build this pipeline for all the cities. So let's start in detail from these methods because there are some things that are needed to be clarified. How was the OD sampling done? So I already told you there's this buffer from the city center. And then what I did was selecting randomly destinations based on the buildings and weighted by their height, so that the buildings with, sorry, not by height, by volume, so that the buildings with higher volume would attract more trips, more people, right? And then I had to sample the origins from there, which were not weighted by anything. I also tried to calibrate the distance of these 20,000 trips by a function, a logonormal function that was calibrated for cycling trips, but in this case for bike sharing cycling trips in Chicago. Yeah, and then all these origin and destinations were in this global H3 grid that you probably are familiar with this resolution, which is the resolution number 9, which correspond approximately to some blocks in a city center. Okay. Okay, so how does this translate to the sampling method? So here on the left side, you see the sampled origins, and on the right, the sample destinations. As expected, the buildings with a higher volume would attract more destinations, and then the origins will be just sampled, but as long as they follow this decay curve distribution of the trip length. So this is the example for Sydney. I mean, universities, airports, schools, and buildings with much more volume would attract more trips, okay? But that doesn't mean that another smaller building also doesn't attract trips, it just attracts less trips. This is how it looks for London, if you are familiar with London. From Santiago, you can see a more diffuse distribution of the destinations. Tokyo, São Paulo, it's even more diffuse, probably because there's not the volume of the buildings are more distributed instead of having these very large ones. And Shanghai, I mean, there's for all the 50 cities. So just to show you the effect of this calibration distance. So if I would just randomly sampling these 20,000 OD pairs, the curve of the cumulative travel distance would be something like this, right? So which would mean that trips for above 5 kilometers will be about 75%, which for cycling is not it's not the reality. So by adjusting these 2 urban cycling trips, it was actually making that the curve would hit about the 70% of the trips will be lower than 5 kilometers, which is much more realistic for cycling. Okay, so how did I classify the cycling infrastructure? I classify in 4 types. I mean, Some may argue that this is not cycling infrastructure, some of them, but I try to also follow the guidelines of the United Nations. So I just did some simple queries for the cycling infrastructure based on the OpenStreetMap tags. So they were divided in protected cycling infrastructure, painted, which is bike lanes that are not physically separated from the carriageway, sharrows, so you know this, I'll show you later some pictures, and foot that is shared with pedestrians. This is just a simple, this script doesn't include all the tags that I used, but it's just an example. So here are some examples of what I mean with protected cycling infrastructure. You can see here bidirectional infrastructure that is physically separated by of the road carriage and physically separated from pedestrians too, okay? This is painted, so a bike lane, here also a bike lane, that has no physical separation from motor traffic. Then the mixed with traffic or sharrows are usually paint on less busier roads, or at least where they try to calm down traffic. And share with pedestrians, that can be anything. It can be a sidewalk where bicycles are allowed. It can be a lane that is shared with pedestrians where pedestrians are allowed, a path in the park. It can be anything, basically. So here we see some examples of the cycling infrastructure evolution by type. And as you can see, some cities differ of their policies of investments in cycling infrastructure. Some of them rely mostly on separated cycling infrastructure, the protected one. Some of them use a mix of painted and protected, and sometimes some sharrows. And some of them are just using mostly sharrows. And here we can see, besides that, also how the cycling infrastructure also evolves between years. So you can see that it starts from a more diffuse network, that it gets more denser and denser. This is the Santiago. London, you see a lot of fragmentation in the beginning, but then trying to close some gaps. Brussels, the same, closing the gaps, but also adding more infrastructure. Christchurch, Montreal, you can see a lot of a higher density there of bike lanes and protected infrastructure. São Paulo, well, this is the typical cycling evolution where you can start from a lot of fragmentation, and the main goal is then ideally to close all those gaps and to have a strong and connected cycling network. Maybe in 2026, a lot of cities are still not there. Some are more there than the others. They have different phases of evolution. Okay, so regarding the level of traffic stress, does anyone ever hear about this or used it before? Yeah, okay. So this is a classification from the Magnetic Transport Institute. It's a bit old, but it's used a lot in cycling. So it classifies the traffic stress in 4 levels. They are a bit, I would say, subjective sometimes, but then we try to translate subjectivity and objectivity to measure how is the traffic stress in each way. It means that for the lower traffic stress, the LTS number 1, it's like a path in a park. It's like a path on a riverbank esplanade that anyone can bicycle. There's no, it's not mixed with motorized traffic. A kid can ride a bicycle there and feel safe. Then the LTS2, which is still comfortable, but maybe not for kids. And then we end up with LTS4, which is just uncomfortable, very stressful, a lot of traffic volume, speed, and so on. So the Conventional, that is the company that I'm using the routing engine, the R5, they adapted this classification and applied to all the OpenStreetMap ways using their tags. So for instance, the LTS1 is defined by if it doesn't allow cars, or if it's residential, it will be LTS1. Maximum speed, number of lanes, also define LTS2. This is also like by exclusion of the first ones, okay? Then in the end, if the highway doesn't fit any of the previous criteria, it will be classified as LTS4. Okay, so this is just the analysis of the LTS levels on the road networks for each city. And you can see here there are some changes, but most of them can come from OSM tagging, how people do the tagging, because as you know, OSM is a collaborative platform that anyone can go there and just change tags. But it should make some sense. So you can see here Melbourne, you can see not only that the LTS levels are changing towards a more safe, less stressful streets, but also the OSM becomes much more rich. You see much more density of segments, and that doesn't mean exactly that there are new streets showing up, right? Paris, here you can see an approach towards more or less safe streets. And you can see that because they also are doing a lot of implementations and reducing traffic speeds and so on. Kyoto, I don't know, I'm not familiar with, but maybe you are. San Francisco, you can also see some changes, well, and so on. London. Why does this matters? Because in my routing engine, I use this level of traffic stress to define what is the maximum LTS that cyclists are using, which means that if I set this maximum LTS 1, only the streets or the roads that are classified as 1 can be used by cyclists with a cycling speed. Otherwise, if a road is number 2, it doesn't mean that cyclists cannot ride in it. It just means that they have to dismount the bicycle and walk. So the engine just penalized the cost of the time by 3 times. So instead of using the speed of 12 kilometers an hour, it uses 3.6. Okay. So it means also that if I use a maximum LTS speed of 4, cyclists just can use any roads, and that would mean that the shortest path will be found, right? This is great, and it's a very simple routing engine, and that's probably why I selected this, because it's very easy to explain it. I mean, there are other routing engines, but they are not that easy to define the costs of the travel, or at least it's not so obvious to explain. Okay, but we have some problems here. For instance, a residential street, which will be classified as LTS1, will be attracting the same as a residential street with some kind of cycling infrastructure, right? Or a residential street with no cycling infrastructure can be more attractive than an arterial with a higher LTS, but that also has cycling infrastructure. This is Lisbon, by the way. Very beautiful city. And again, even if we have a cycling infrastructure that it's more protected, or at least it's a bike lane, it's not some sharrows, the residential street will still be preferred on the routing engine, okay? So just an example, this is just a conceptual street. If I just use those LTS levels, it means that a cyclist that starts here and wants to go there will probably just do this, enter a very busy street, but go to the back street and then go again to the very busy street, instead of just using the cycling infrastructure that exists there. This is probably what happens in real life and not this. Here, another example. So the routing maybe would choose this one instead of this one, despite this one having a cycling infrastructure. It will be treated the same. So how to overcome this? So for each year, I just created a list of all the segments that I classified as cycling infrastructure segments. And I say, okay, for these ones, let's treat them as they are level of success 1, so that the routing engine will always prefer, I mean, it's always preferring the ones, but at least a residential street will be weighted the same as, will have the same cost as a tertiary road with cycling infrastructure. Okay, so we can just to visualize what it means in the end, I just put all the routes together just to make sure that my algorithm routing is doing exactly what I wanted. I was just comparing the routes that it was making for the 20,000 OD pairs. And yes, I mean, you can see it here where some infrastructure is added. You can see there are some changes in the routing, right? Here, for instance, between 2021 and 26, there's this one, which I think is probably Oxford Street. I don't know, not sure. And this for all the cities. We can also see that the trips were more maybe diffuse. And then when you're adding more cycling infrastructure, the routes of cyclists will be more convergent to the cycling infrastructure. And this is what we wanted to do with the routing. So the same for Brussels. Milan, you can see there's more like a road network itself forming. So another thing that I wanted to measure was the number of interruptions at the route level. And for that, I just created this very simplistic way, which is if a route is using cycling infrastructure and then stops, is using like a non-cycling infrastructure and then goes back to the cycling infrastructure, that counts with 1 interruption, as long as this distance between them are at least 100 meters. Okay, because in OSM, some of the segments are drawn, and then there's the crossing, and then there's again the segment, and there's a separation between segments, and that wouldn't be realistic counting as interruptions. But I mean, this is a parameter that we can easily change for 50, I mean, whatever. Also, how is the accessibility estimated? So this is a cutoff of 15 minutes from the origins, and is estimated by the volume of buildings. So if you can access a higher volume of buildings in 15 minutes, you probably will have more opportunities, access to more opportunities. Which means that if you add a new cycling infrastructure, you'll make this trip virtually faster for those 15 minutes cutoff, or even unlock some new road that there was a barrier and you couldn't cycle there to reach those destinations in the 15 minutes. So just another concept, probably you already know this. What is circuity? Circuity, it's the route length divided by the Euclidean distance from O and D, so the linear distance, which means that if you have a circuity of 1.4 or 1.2, the route will be 40% or 20% longer than the linear distance. And just another score that I came up just to assess the stress of the route, which will be a combination of the percentage of the lengths that is using LTS 1, 2, 3, or 4, weighted by 1, 2, 3, or 4. And this is a score for the route itself. Okay, so if you have a score of 1, it means that all your route is using LTS 1. Okay, so just to recall the question, what are the systemic and route level impacts of adding 1 kilometer of cycling infrastructure on these variables? And came with a fixed effects panel regression and divided as macro level to see the effects of the whole cycling infrastructure impassion, and micro level at route level. So here is the formula for estimating these impacts, the elasticities. So here in our dependent variable, we have the outcomes for the average trip duration or the accessibility for each city and for each year. We have this with the total cycling net infrastructure, and for I wanted to control also for the total road expansion, total road OSM drawing in the city. And then we have the city and year fixed terms plus the standard errors that were clustered by city. So the results in duration and accessibility. So in a accessibility, as expected, it would increase, right? Because you are providing faster routes for the 15 minutes. And for the duration, it would decrease actually the cycling, the average of the trip duration, because then the routing would make the cyclist look for a safer segment to go on the route. So it creates a higher circuity, right? And for instance, here, 10% of cycling infrastructure added decreases 1.45% of the trip duration. So yeah, just to remind that this duration, it's not it's the impedance of the costs and not the duration itself, okay? Doesn't mean that the cyclist will go faster. So at the micro level, so at the route level, I wanted to see the impacts on the same route characteristics. So what it means is I'm using the same 20,000 OD pairs. Those are always the same, and those are fixed, okay? Only the route will be different and using different types of facilities. So in this case, I'm assessing by type of infrastructure. So what are the results? So here we have about 5 million routes, right? That are also clustered by city. And we see that per 1 kilometer of protected cycling infrastructure added, there's a higher circuity, about 6%. And this is this is already explained in the literature. This is how the cyclists behave. So it makes sense. And the duration will decrease, which was also expected. So there's like a trade-off here for the cyclists. They accept to make a higher detour, to make a longer route, to have a safer route. In terms of interruptions, so the number of interruptions for each route, it decreases by kilometer added of protected cycling infrastructure, about 0.08 interruptions per kilometer. So if your trip has 10 kilometers, this will be much higher. But the other painted lanes also decrease, but we cannot conclude anything about the shallow ones. Regarding the safety or the less stressful routes, we can see here an interesting thing. So it decreases a lot the percentage of the route that's using LTS1. So it means that if I'm putting a bike lane in a LTS3 road, the trip will choose to go by there, but it's a more stressful environment, right? And same with the sharrows. What is interesting here is that for the stress score, it also increases a bit. But what we can think about here in terms of planning cycling infrastructure, so you usually put a bicycle lane or a busier street, and you put a sharrow on a more quiet street, more residential street, and this probably can be correspondent with that difference. Protected cycling infrastructure. Here we have two things. One of them is some protected cycling infrastructure is added by removing a car lane, for instance, so or lowering the speeds of that street, or lowering the traffic volume. But also we can see that there's a problem with OSM. I wouldn't say a problem, but this also helps to justify, is that usually a protected cycle lane is drawn as a separated way than the main road, while the bike lanes and sharrows are tags on those roads. Okay, so this separated lane, separated infrastructure will always have LTS1, but these ones don't exactly have LTS1 but originally. Okay. I was also comparing this. So if I just classify everything from OSM to LTS1, the cycling infrastructure. So first I was just saying the route to use other LTS levels. Here I'm comparing with if this route, these segments were actually LTS1. So I can see that it's using more LTS1 each route. And the differences are not very high between different types of infrastructure, but are high for putting the cyclists into more stressful roads. So just to sum up with what are the findings of this ongoing research. So the average duration at macro level, it decreases about 1.45% per 10% of cycling infrastructure growth, which is a good result and expected. The accessibility increases, so cycling network infrastructure unlocks new destinations or make them faster virtually. The detours like increasing the circuity or increasing the route length to trade off with safety is verified here, which is in real life what sometimes it happens. The trip is faster, also about 1.3% per kilometer on the protected cycling infrastructure. And we can only say conclusions about the protecting cycling infrastructure that is closing gaps with the interruptions of the cycling network fragmentation. But we know that the cities are at different stages of cycling network expansion and fragmentation. So this is something that we can come up with another way of measuring this. Yeah, so adding cycling infrastructure works for all these things that I wanted to assess. And the ones that are more protective, the protected cycling infrastructure, are more continued, will bring better results in terms of cyclists' trip efficiency and so on. What are the limitations? Well, there are some, as you probably saw. About the routing engine and how it works, I already explained a bit about this. And how R5 works regarding the LTS1 level. So some streets are still treated as equal, some residential streets and some cycling infrastructure streets, in this case, are still treated as equal, okay? The OSM data quality, I mean, this is no novelty, but there has been a lot of growing in the contribution, so more people are contributing to OSM. But also there are some limitations here, like sometimes the cycling tags just change. There's new direction of how to tag this cycling infrastructure, but they do not apply to the previous years that were already locked in their data sets. Also, maybe there are some new cycling infrastructure that it shows as new in our OSM, but it was always there, just someone didn't have the time to contribute, to tag it. Yeah, and the fragmentation also increases when we are putting a lot of realism in our drawing. So as I told you, bike lane can come here, and then there's the intersection, and then there's a new segment instead of just having a straightforward lines. But I would say that these limitations regarding the routing engine and OSM, I mean, if you want to use open data sets and open engines that are easy to explain and so on, there's not much that we can do better than this. So what are the paths for further research? The next step will be to scale up for more cities in the world, 200, 300, whatever. Have more time points, or at least have the 10 years or make it even years. Also, there's a step that I still have to do, which is to validate the OSM tag. So look at pictures, look at different dates and see if they are the simplified version of the reality is valid from the OSM maps. Also develop another metric to measure this network connectivity score, and of course to submit a paper with this research. Yeah, that was it. Thank you.
So about your takeaway findings. So I expect that when a network is very immature, for example, 10% of the network is cycle rate, the 10% growth would affect differently when it's like 50% mature compared to when it's 90%. We sometimes growth, the effect of growth matters on the current state. Your analysis is kind of going to average it out, it doesn't consider that, or?
To consider the evolution.
So can you go back to what they? Here, 10% growth when the network is going from 0% infrastructure to 10%.
Mhm.
I expect to see different outcome when it's going from 50% to 80%, or from 90% to So the effect of growth matters on the current state of the infrastructure. What is I expect? Like what do you expect?
Yeah, I would say somehow yes, but I'm also applying here the fixed effects of the city in the years that are somehow absorbing those differences, like from a city that has a very elaborated network and a city that doesn't. And again, this one.
You're looking at the absolute accessibility as a function of the absolute size, total segment structure here. Blah, blah. So would it make sense if the differences model would change accessibility, change segment structure, change again size of the segment, size of the infrastructure as factors are very close.
Mm-hmm. Okay, yeah, I understand your question. Yeah, that's something that I should explore. Yeah, it would make more, at least try to see if there's something that is missing here. Yeah.
Some questions online too. First one is how the short distance that is inherent to cycling matches the city scale network. And the second question about if the scalability of the different types of infrastructure is the defining factor more than identifying a specific optimal type.
Okay, so regarding the scale of the city, that's that doesn't matter because we are using the same area. So this city buffer, and they are the same 20,000 ODs, and the trip distribution is the same. So they all follow the same trip distribution. So that doesn't it's not a relevant aspect for this modeling. And the other one was about the type of infrastructure.
Type of infrastructure, namely the scalability is the defining factor rather than identifying which is the optimal.
The scalability of the cycling infrastructure.
Different type.
Okay. I don't know if I'm understanding very well the question. So there are, I mean, the cities are growing in different types, right? Some of them are investing more in one type, some of them are investing more in other type. These are the city policies. But all of them are growing. And I would say most of them are investing more in protecting cycling infrastructure than the other types. Okay. I don't know if someone can help me about this question.
It's more about the cost of the different infrastructure.
The cost. Yeah, I mean, it's cheaper to put sharrows in back streets and say that you increased cycling infrastructure by 10%, right? But as we see here, that doesn't provide more less stressful spaces to ride, or yeah, that. But I also should divide these macro levels with different types of infrastructure to see if that also applies to more to shareables or more to protected or more to bike lanes. Yeah, that's something that we're also going to do.
Another question. So at the beginning, you were also mentioning as one of the aims to relate this to safety. My question is whether it's possible or if it's the plan to combine this analysis with data about crashes or
yeah. That will be interesting. It will be other type of model, of course. And if there's open data sets for all the cities, I'll be happy also to do that, or someone can just from here try to analyze that. Yeah, I mean, safety in cycling, it's a interesting thing to measure because there's a huge misreporting, right? A lot of stressful situations that cyclists face that are never reported or accounted for, but they are still there. And probably you have more of them in the intersections itself and not as much in the linear infrastructure, which is the traffic stress that I'm here looking at. It's not the infrastructure. But yeah, that will be interesting, but it would also have a lot of caveats regarding how cycling injuries are reported or.
From what you were saying, one could actually expect, I guess, the same that you were mentioning, that as you put more infrastructure in our streets,
This one?
that will promote, yes, it will promote more people cycling, but it's also going to bring the cyclists.
Yeah, to our period.
Places.
Mm-hmm.
So the effect is less obvious.
Mm-hmm. Mm-hmm. Yeah.
What are you using? Do they have any other land use?
No.
So, big warehouse.
Yeah.
For you, then probably look like CBDs.
For sure. Yeah. But yeah, the cost, I mean, it's not a cost, it's a trade-off, but of using an openly available database or no, or just going there and see what's the land use and everything. I mean, I'm fine with this origin destination sampling. I think it somehow translates a reality. Of course, there are some limitations of where the routes, the ODs are, maybe very peripheral or not going to the places where people have trips. This is not only for commuting trips, of course. I mean, it's for all trips. So we don't make that difference here. These data sets, they have, if the source is OSM, you can go to the OSM tag and see the type, if it's filled there in the OSM. But it combines a lot of data sources. It's not only OSM. So there's no way of saying exactly. Maybe you can say with confidence interval that some % of buildings are residential, some % are services or education or whatever. But yeah, that will be another step forward but that will be probably another paper of how to generate OD pairs for trips using these data source.
Part of her plan to see cycling infrastructure and this one like there be a plan to see if investing in personal?
Mhm. Well, we are not directly assessing usage, right? I mean, there are some ex ante and post studies that can compare that with counts and if just to verify if that public investment was beneficiating a lot of users, right? But here we are simulating if cyclists would prefer that route instead of the other, right? And yeah, when we are looking at elasticities, we are trying to see if 1 kilometer or 1% investment in this type of infrastructure would make them the routes safer or provide more accessibility, and so on. Okay, let me just. Thank you. Well, I just wanted to thank everyone and thank Professor David and Professor Andres for organizing this. Also, these are my contacts if you want to reach out. And thanks everyone. So I'll leave next Wednesday.